Hey guys, we're moving on to 14.6, which is exponential growth and decay using regression. Now, if you look at this first example on our notes, it says, how do we find the equation to model this linear data? Well, we know how to do linear data all the time. And we talked about this when we had trend lines. We have to take all of the data that they give us and we put it into our calculator. So I'm going to go to my calculator on my screen. And I'm going to press Stat, Enter. I'm going to plug in all of my x values into L1. Now the reason we're not doing 2 is because it's not a perfect line. It's a bunch of data. It's not a straight line like it normally is. This is a bunch of data points, and we're trying to draw a line of best fit through the data. So we need all of the points. So we're going to put 10, 13, 15, 19, 21. Oops. And then we go over to L2. We're putting all the y values. So 65, 72, 75, 85, and 90. Now, from here, we're going to go to Stat, over to Calc 4, just like y'all are used to. Enter, enter, enter. Enter. So when we get there, it gives us the equation y equals ax plus b. But instead of y equals ax plus b, I know what a is. A is like 2.26-ish. X plus 42.18. So there's my linear regression for this model. I can make a line of best fit that goes through all of these data points. And what I mean by line of best fit is, there we go. Like these data points, they're all over the place. It's not on a straight line. It's not going up at a constant slope, a constant rate. But I can draw a line that goes through most of these points and follows the trend line. That's what we're doing. And that's why I need as many points as possible because it's not a perfect line. Just wanted to explain that a little bit more. So this is called linear regression, and we use it for lines of best fit, or again, trend lines. We're making a line that follows the trend of what seems to be happening. It seems to have a positive slope. As my x goes up, my y's are going up. Well, guess what? We could do the same exact thing with exponential functions. No way. It's called, you guessed it, exponential regression instead of linear regression. So instead of having it in the form y equals mx plus b, now we're going to have it in the form y equals a times b to the x. This is how you do it on your calculator. So same kind of steps. In L1, you put all of your x values, just like on linear regression. And remember, we have to use them all because these are just random points we're trying to find the line of best fit. L2, we put all our y values in. Again, same. And then this time, instead of StatCalc 4, you're going to hit StatCalc 0. StatCalc 0. I'm going to go ahead and write that's a 0. StatCalc 0. So using this information up here, let's answer these questions. What exponential equation models this data? So first I've got to find the equation, which I can do by plugging it into StatCalc 0. So I'm going to go over to my calculator. I'm going to go ahead and clear mine. Second plus 7, 1, 2, enter. And I'm going to go to, it'll load, there we go. Stat, enter, just like we do for other, linear regression. Now I'm going to plug in these numbers. So I've got 0, 1, 2, 3, 4, 5, and 6. Then for L2, I'm going to arrow over 110, 147, 172, 233, 318, 395, and 433. Now all that my information's in, we're going to go to Stat, like we normally would, over to Calc. Now, instead of hitting 4, we're going to hit 0. And if you notice, there's not 0 on here. So you can either just type in 0, or if you scroll up, it's right here. Exp regression. EXP-REG, which stands for exponential regression. So again, I'm just going to probably hit 0. If you want to scroll and press enter, you can. So 0. Then you press enter until you get to the next screen. And once I'm at the next screen, it tells me what my A is and what my B is, and I just fill it in. So now I've got Y, whoops, writing in highlighter. Y equals, instead of A, I got 112.72 times my B, which is 1.27 to the X power. Now we could also write it where we break up this part to where it's 1 plus or 1 minus, which I'm going to go ahead and do just so we can see what's going on. So I've got all of this stuff's the same. Y equals, make this bigger, 112.72. Now this time it's going to be 1 and it's either plus or minus. And this time it's plus because it's greater than 1. 1.27 is greater than 1. And 1 plus what gives me, 1 plus what gives me 1.27? Well, 0.27 to the X power. And because of this plus sign, I know it's growth. It's going up, which makes sense because my table values is my X go up, my Y go up. It says, how many internet hosts were in the year 2001? Well, it says years since 2000 is my X, number in millions is my Y. Well, years since 2000, 2001, that's what we're looking for, 2001. So we've gone 0 years from 2001. We're still in 2001. So this right here is 2001. So if I've gone 1 year from 2001, I'm in 2002. 2 years, 2003. 3, 2004. 2005. 2006. 2007. So I'm looking again for 2001, which is right here. So in 2001, I had 110 million, according to my table. How many internet hosts were there in 2005? Go up to my table. Oh, look, right here. 2005, 318 million. Again, it's in millions. What is the average growth or decay? Circle 1. So we already set up here, we said it was growth because of this plus sign. That means it's growth. If it were minus, it would be decay. So first off, we know it's growth. And it wants to know the rate. The rate is in a percent. Well, this right here is my rate, 0.27. In order to change it into a percent, I just move my decimal place back over. So, or 27%, which I prefer this form in rather than the other form. But I won't count off. Then it says, how many internet hosts in millions is there predicted to be in the year 2017? Well, if you notice, year is my x. So in my equation, y equals 112.72, 1 plus 0.27 x. I'm going to be plugging in for x and solving for y. So I want to know in the year 2017. Well, if you notice, it's years since 2001. So instead of putting in 17 years, because we didn't start in 2000, it's going to be 16 years. So instead of x, I'm looking for when x equals 16. So everywhere I see an x, I'm plugging in 16. So it's y equals 112.72 times 1 plus 0.27. And then instead of x, I'm plugging in 16 and solving. So I can go back to my calculator and I can plug this in. If I go to second mode, I go back to home. So I've got 112.72 times 1 plus 0.27, close parentheses, the little caret button takes me up, and I'm moving to the 16th power. So if you can see, y equals 5162, we'll say 0.5 million. So it's a big number. Which makes sense, we're growing, we're going up. So that makes sense to have all the way down the road here at 2017 to have that many. So make sure it makes sense. Okay, let's try number next. Oops, that's not number next. Here's number next. Okay, the table below shows the population Y of Middleton, where X is the number of years since 2000. It says, what is the population in the year 2000? Well, this says years since 2000. So if I want in 2000, it's got to be 0 years. So I'm looking here. So the population would be 5,005. And it says, what is the population in 2005? So I'm looking at, well, this is 2000. Oops. This is 2000. Then this is 2001, 2002, 2003, 2004, 2005, 2006, 2007. And again, I'm looking at for 2005, so I'm looking here. And in 2005, I've got 12,420 people. It says, what is the exponential function that models this data? So now I've got to take this data and plug it into my calculator and do StatCalc 0 because it's an exponential function. I'm going to clear my calculator. And I'm going to stat, enter. In my L1, I'm putting in all my x values. So 0, 1, 2, 3, 4, 5, 6, 7. In L2, I'm putting in all of my y values. So 5,005, 6,010, 7,203, 8,700, 10,521, 12,420, 14,982, and 18,010. Okay, so once I get all my values in, I then go to StatCalc, and I'm going to press 0 because it's exponential, and I press enter until I get to the next screen. There's my A, there's my B. So when I go to write, I've got y equals A, 5011.45-ish times 1.2 to the x. And again, I'm rounding. Another way to write this would be y equals 5011.45 times 1, and again, it's over 1, so I'm adding, and 1 plus 0.2 gives me 1.2 to the x, so either one of these works. This one, I think, helps you be able to read for this next question. So it says, what is the average growth or decay? Well, again, since I'm adding, it's growth. And the rate is here, 0.2. To get it in percent, like we want it, we're going to move it over twice. So it is 20%, and I prefer percent again. Then it says, what is the predicted population of Middleton in 2011? So I'm going to have my equation, y equals all of this. I'm just going to keep it 1.2. Instead of x, though, I want to know when x is, well, years since 2000. I've got to go 11 years past that. So we want to know when x is 11. So everywhere I see x, I'm plugging in 11. So instead of x, it's going to be 11. I'm going to plug this into my calculator. Second mode. And I'm going to plug in 5011.45 times 1.2. And again, if you want to do 1 plus 0.2, either way works. And then I do the caret button to the 11th power. And I get y equals 37,235 point, we wouldn't say 0.5-ish. And since it's talking about population, can I have 0.5 of a population? I can't have half a person. So I'm going to round this to 37,236 as the final answer. Okay, number last, we're almost there. Table shows the value of a car every year since it was purchased. It says, what is the original cost? So when it was 0 years old, what was the original cost? Well, it tells us right here in the table. The original cost was, whoops, $25,000. How much was the car worth after 5 years of owning it? So I'm going to go down until I see year 5. There's year 5. And it's worth $11,203.56. Now it wants to know the exponential function that goes with this data. So I'm going to go back to my calculator, clear it, second plus 7, 1, 2, enter. I'm going to go to stat, enter. I'm going to plug in all of my x's into L1, all of my y's into L2. So I've got 0, 1, 2, 3, 6, 7, 8, 9, 10. I'm going to go over L2. I've got 25,000, 21,462.5, 17,881.88, 15,506.66, 12,919.65, 11,203.56, 9,523.03, 7,934.28. Geez, these are big numbers. 6,880.03. 5,732.52. 4,872.64. Okay, now we go back to stat. Let's try that again. Over to calc, and again it's exponential, so I'm hitting 0. Enter, 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 enter. And I get my A, and I get my B. So I've got y equals A is 25,101.7-ish times, say, 0.85 to the x power. Or y equals 25,101. And I could do 1, since this is less than 1, it's going to be minus, well, 1 minus 0.85 equals 0.15. So 1 minus 0.15 will give me 0.85, and again to the x power. It says, what is the average growth or decay rate? Well, again, I'm looking here. It's minus this time, so it's a decay. It's going down. My car is getting less and less every year I own it. And the rate is this, 0.15. And again, bring it over 2 times to get the percent. 15% is the rate. It says, what is the predicted value of the car when it is 13 years old? So I'm going to plug in y equals 25,101.7 times 0.85, and instead of x, this time I'm going to plug in 13. And when I do that, I'm going to plug it in my calculator. I'm going to plug in 25,101.7 times 0.85, and then caret to move it to the 13th power. We want to know it's 13 years old. So it's equal to 3,034.93. 3,034.93 is what it's worth. And this one wants to know, in what year is the value of the car less than $1,000? Less than $1,000. So we are going to plug in 1,000 for y, 1.7, 0.85 to the x. And you could plug this in Desmos and see where the graph crosses. You could literally plug it in. So if I went to Desmos, start graphing, 1,000 equals 2501.7 times 0.8 to the x equals. Now I want to change that to y actually, because I want to look at the graph of this. We need to zoom it on out because we're talking about majorly big numbers. And we want to know when the price, which is y, is less than 1,000. Well, there's 1,000-ish. About right there. So it's about 20 years is when it's going to be less than 1,000. Because if I'm right here at 20 years, it's going to be less than 1,000. So when x equals 20 years. So I would just graph it and look and see what Desmos is doing here instead of sitting there and solving. Hope this helped. Remember, it's StatCalc 0 for exponential regression. Thanks for listening. Bye, y'all.